Rescue and surveillance robot is a six-wheeled wireless multi-terrain robot which is made using the rocker-bogie mechanism.
The rover is manually controlled by the operator by using an Android application. It is capable of navigating through rough terrain, at the same time provides critical information to the operator.
The rover is capable of providing a live video feed as well as real-time sensor data to the operator by means of a dedicated Windows Phone application specifically designed for our project.
The rocker part of the suspension comes from the rocking aspect of the linkage on each side of the rover. These rockers are connected to each other and the vehicle chassis through a differential. The chassis maintains the average pitch angle of both rockers. One end of a rocker is fitted with a drive wheel, and the other end is pivoted to the bogie. The bogie part of the suspension refers to the smaller linkage that pivots to the rocker in the middle and which has a drive wheel at each end. In order to go over an obstacle, the front wheels are host against obstacle by the rear wheels. The rotation of the front wheel then lifts or front of the vehicle up and over the obstacle. The middle wheel is pressed against the obstacle by rear wheel and pulled against obstacle by the front, until it is lifted up and over. Finally, the rear wheels pulled over the obstacle by front two wheels. During each wheel's travels of the obstacle, forward progress of the vehicle is slowed or completely halted.
This device has three main parts: control unit, rover, and a Windows application. The device is wirelessly controlled using an Android application. The wireless connection is established using Wi-Fi technology with the help of ESP8266 Node MCU. A 12-volt 60 RPM DC gear motor with 3 kg/cm torque is used. A 5-megapixel Pi camera is used here. It is connected to a Raspberry Pi 2B Plus module. This camera will live stream video in the Windows application, so that remote or risky areas where it is difficult for human beings to reach can easily be seen through the camera. PIR motion sensor is attached to ESP8266 Node MCU. It allows to sense motion, almost always used to detect whether a human has moved in or out of the sensor's range. Ultrasonic sensor is connected to ESP8266 Node MCU. It measures the distance of a target object by emitting ultrasonic sound waves and converts the reflected sound into an electrical signal.
MQ5 gas sensor is connected to the Node MCU. It is suitable for detecting LPG, natural gas, coal gas. It avoids the noise of alcohol, cooking fumes, and cigarette smokes. All these sensor values are uploaded to Google Firebase's real-time database. A Windows application is created using Visual Studio. It has a screen to display the output from the camera. It also has columns to display the output values of different sensors. On clicking the Connect button, the app establishes a connection with Raspberry Pi and starts displaying the live feed from it. On the right side, we can see all the sensor data that is being retrieved in real time from the database.
This device can be used in situations like fire accidents, landslides, accidents in mining areas,